Thanks, Joe. I have to make a confession just to start, which is when Joe, through Stephanie, invited me to come here, I thought, great, I'll come. There'll be all these smart people. I'll give a talk. Housing in San Francisco is so expensive. Seattle is happening. I'll recruit all of you to come work at AI too, because we're hiring, in the talent wars and all that. But having walked over here in the sunshine and seeing this space, I think it's turning on its head. And so my first question is, do you guys have an extra spot for a guy from Seattle? Because this is so cool. I really want to be here, just not go back. That said, what I thought I would do is show you a little bit about AI too, but not in terms of a recruiting talk, but more in terms of some of what we're doing. And I'll show you a few demos. A picture's worth 1,000 words, a demo is worth 1,000 pictures. And I understand that most of you have a technical background, but most of you aren't AI experts. So a great way to kind of get a sense of well, how well does this AI thing work is to just look at some examples of AI in action. And because John is here, and he and I have had long conversations when he was a reporter at Science Magazine about Semantic Scholar, I thought I'd start with our first project, which, of AI for the common good, and that's the Semantic Scholar project. And the idea here is to use can people see this? Almost okay. To use AI to help you cut through the clutter. So the backstory is there's something I like to call Moore's Law of scientific publication. Every couple of years, the number of scientific publications is doubling. And the ability to find what you're looking for becomes increasingly hard. So here, let me do a query I've never done before. These actually rotate. Let's say I'm interested in learning about cybersecurity. Who isn't? So I'll click on that, and maybe I want to look at this paper. If you want to read the paper, you have to go to IEEE. There's a whole story here about open access that I'm not getting into right now. Big conflict on that. But for example, we've automatically identified the topics in this paper with some degree of accuracy. We went to the PDF file. We're able to automatically extract the figures and tables, which is really nice on a mobile device, and you can kind of flip through and get a sense, right? This is this kind of paper. Looks like it's big on the figures, not big on the results. And please turn off your cell phones. It's an intro to talk. Anyway, so you get a sense. Often these are a lot more meaningful. We also use AI techniques, right, to suggest, okay, let's look at related papers, et cetera, et cetera. One thing I was just showing John earlier is that when we look at the citations, there are often, these papers will have hundreds of papers that cite them, and those papers will have hundreds of papers that cite those. And as you try to navigate the citation graph, I think we've all been there, right? Digging up on some technique and what's been done more recently and what's really the state of the art. You just get lost, right? There's so many papers, so many citations. So we use machine learning techniques to identify meaningful citations, right? Which are the citations that really matter? And so you see here the top citation here, paper A, highly influenced paper B. If you're wondering why, you can look at citation excerpts, what this paper said about the other one. And I'm glossing over the details in the interest of speed, but the point is we're able to achieve a factor of 10 reduction in the number of citations you have to look at to make sense of things. So out of, say, 156 citations, maybe only 15 or 16 would be what we call highly influential ones. So check out Semantic Scholar. It's free. It's available. We have about 6 or 7 projects at AI2. Vision, we have an incubator where it's not unlike South Park, right? We launch our own startups. But what I wanted to show you is a project, again, this is an open source project called Allen NLP. And what this is a library built on top of PyTorch to make it easier to use and build and extend state-of-the-art deep learning models for natural language. So let's have a look at the demo. We have here about 6, and the number keeps growing, models for various tasks. where the state-of-the-art models are implemented in our system. And this is where I thought it would be helpful to give you a sense of what can we do. So let's take, for example, something that's called coreference resolution, which is a jargon way of saying we're going to figure out what he, she, and it refer to in a sentence. So I'll try to show you an example that works, and then we'll try to break it. And that's where you get a sense of what we can do. So if we take, I don't know, this sentence, I guess this is, a paragraph, right? Quite a bit of information. And we run the model. It's already been trained. What we can see here is, these was bound to presentations, and this name is the same. Probably not the most exciting example here. But where it gets more interesting is, okay, we like to have our demos be open, so you can type in what you want. So let's say I say, Susie sells seashells by the seashore, and it is a very happy day, right? So simple sentence. Let's see how our state-of-the-art, and you'll have to take my word on this, but these are very much state-of-the-art models that we've faithfully re-implemented. So this is the document, and if we go higher up here, we see the clusters, and it looks like it completely failed to find anything. All right, so let's modify this to make this, okay, if we say, and she is very happy, that's too easy, right? Because, let's see, she sells seashore to Joe. Again, I don't want to make it too easy. And he is very happy. That should succeed because of the gender sync, but it didn't, right? So somehow it decided to bind Susie to he. Yeah, I'll send that message. Sure looks like a bug. It should work. It should work better than that. Let me try another one. So this is a task that's called textual entailment. So that is, for example, if you have a sentence like the premise is, right, you're trying to deduce something from a premise. So if you help the needy, God will reward you. That's the premise. And the hypothesis, what you're supposed to infer, I shouldn't say deduce, is giving money to the poor has good consequences. And remember, it's operating at the text level, right? It's really trying to go from the text, somehow understand it, and decide whether the conclusion is warranted or not. And what would you say? Should it believe in this or not, based on the premise? Not based on your values, right? Just based on the text here. Yes, no?
Seems pretty advanced to understand God reward.
Right.
What's the assumption about that?
Right. So here we see that it actually did quite well. So we see that it's likely that it entails a premise, and it can even provide here. We have the probabilities, and it's a probability distribution. But what's more fun here? Let me open it up. Somebody want to give me a premise and a hypothesis? And the point is that you can't say Donald Trump is president is the premise, and the hypothesis the world will come to an end, right? That's uses a lot of world knowledge, but kind of
Can we try?
Say it.
Can we try it?
Yeah, let's see that one. Let's just see what it says.
I couldn't understand what you
Just
said.
like
Can we
time,
try that example?
Yeah.
Try that, right? Okay, so
It's a good negative example.
yeah, Trump is president, and the world is coming to an end. All right. It's the beauty of this one. Well, it's
We got a 50-50 chance.
well, yeah, it's neutral, but definitely stronger in the entailment that it's a contradiction. Anyway, let me stop there. As you can see from the uncertainty, and you can play with this offline. These things are available 24/7. There's a lot of uncertainty and brittleness, right? The types of things that you would expect to clearly infer. Let's just do a simple one, it is 9 a.m. on Monday, and we want to conclude it is morning in the beginning of the work week, right? Let's see what it does. Again, these are stuff I've never done before. This is off the top of my head. So, it says most likely this is false. Mostly I just have no idea. Okay? And that's the kind of behavior you would expect from Alexa or Siri, right? They don't really understand what you're saying unless you say traffic update. That's my point, actually. Our state-of-the-art models are still very much at the Alexa or Siri level. And if you think about the thousands of people working on Alexa at Amazon, that's actually not surprising, right? If they could do better, they would. So let me just show you one more project, just so you think I'm not a total, I don't know what's the word, skeptic about AI. Let me go back to our website. I'll show you something that we're quite proud of, and that's the Euclid project. Here's our demo. It solves math problems. So here are SAT-style problems. This isn't any math problems, but simple SAT-style story problems. Right now we're doing what's called closed vocabulary, where we use words like product and consecutive integer and things like that. And we consider things like the sum of 3 consecutive odd integers is 9. What is the largest integer? Among those 3, and it comes back with 5. And the thing that's cool here is there's very little training data to understand these types of sentences, and so we've built algorithms that can make sense of this rather convoluted arithmetic sentences without a lot of training data. So again, in the little tradition that we're establishing this, let's open this up and see how quickly we can break it. The only constraints are it's got to be these types of sentences. If you do a problem having to do with Trump, or even having to do with kids, 7 kids got on the bus, 5 kids got off the bus, that sort of thing, that's not what it's meant for. It's more about integers, products, pairs, and so on. Anybody want to? Yes?
What is the square root of the largest negative integer?
So what is the square root, God, engineers, root of the, I'm gonna change that because when it deals with infinity, it gets confused. What's the square root of the largest?
Not maybe not the greatest. There's no way
Not
to
the
work it.
largest.
No, I think he means
Are they both the same?
Is it
The
N?
greatest should be
How's it
of the
well formed? But
greatest.
the largest negative integer?
Oh, man.
Negative 1?
Class. I used to be a professor. I can't hear what everybody's talking, so I'm going to call on you. Yes.
Let's listen to the physicists and call it the greatest
Of the greatest
negative integer.
Of the greatest, I see. Greatest meaning that negative integer. So you're thinking about -1, or
That's one.
That's what I was going.
yeah? I don't think it knows about imaginary numbers. Let's stay positive.
Does it know how to do series? Like if you said, what is the sum of the numbers 1 through 5?
Let's find out. I see some disappointed faces there, but it doesn't know what is the sum of the integers between 1 and 5. Let's start there. Thank you. That's kind of a bounded problem that it got right. Actually, I don't know that it doesn't know about negatives. I've never seen. Actually, it does. Sorry. So, what is the square root? It doesn't know. What I meant to say, it doesn't know about imaginary. What is the square root of the greatest? Let's just start with what is the square root of -1?
Yeah.
Just, baby steps. Baby steps. It's AI. You have to be gentle. That question was a little bit. You guys know about the hitchhiking robot, right? That was going around the country. And then some people found it. I think they were engineers, and they beat it and kicked it, and so it looks like Euclid has gone off the deep end here. I'm not sure what's going on. Anyways. What is the largest prime smaller than 100. That's the sort of thing that it should achieve. While it's thinking about that, I think that's Brian. Yeah. So let me stop there. Again, you guys could play with this offline. I gave a talk today, and I could share with you some highlights about AI and society. And you guys could feel good because at the talk I gave earlier, it cost $1,000 to get in, and you guys can get it for free. But even better than that, I'm happy to just have a dialogue, answer questions about anything. At the end of the workday, who really wants to see PowerPoint slides, right? Hey, were you there? No,
Where was I there?
earlier today at the
Conference. At MSite?
I confused you with somebody else.
All right, never mind.
I apologize. There was somebody wearing the same sweatshirt at the talk earlier today, and I was like, oh. So, please.
Yeah, so Sean and I thought it'd be kind of fun to do a slightly moderated section, but then I think we can just open it up for questions after that. But I just had a couple that I wanted to pose to you specifically. So in your career, you've had a very successful career as both an academic and also in the industry. So Oren has founded at least 2 companies that I know of that were successful, in addition to being a professor at UW. So I think that gives you some perspective on this topic that I'm really interested in, which is kind of how the relationship between industry research and academic research has been evolving, and how has that changed over, say, the last 5 or 10 years, and where is that going? And I think particularly for me, places like AI2 and OpenAI and others are trying to kind of sit at this intersection. But it feels like it's very viscerally that the balance of power is very much shifted towards industry labs, and that may be having some effects on kind of our ability to do basic research. So I'm curious to hear your thoughts on that.
Yeah, so I have a very simple answer to that question, which is you're right. The balance of power, as you're calling it, has shifted, and it's shifted for 2 major reasons. The first one is that it was always the case that if you're a grad student, you get paid. When I was in grad school, whatever I got a fellowship, so I got $1,500 a month. It was in Pittsburgh, so you could actually live reasonably on that, and it was a while ago. But, it felt fine. I didn't feel like I was missing out on untold riches on the other side. It was in the late 80s of the previous millennium, it was a long time ago. But nowadays, right, the opportunity cost, and I talk to young people, right, who are, leaving college or even, think about college all the time, right? The opportunity cost of spending those years in graduate school is tremendous, right? So that's the case. The opportunity cost for faculty members, right? You keep hearing about, this professor was hired away, this professor was hired away by Google, by Facebook, by so many places. And again, it's hard to blame them where a professor's salary may be, I don't know, 150, 200K, and they're, financially it's very difficult to resist. What's even worse, though, is that the computational and data resources available at these companies are also very compelling. So even if all you care about is doing the best research, there's an argument to be made that you should do it at one of these major corporations. So that very much reflects the change. And the reason that it's a problem is, look, where did all these companies, not all of them, but many of them come from, right? They came from universities and from, be it Google or Yahoo or in Seattle, other companies. And even if they didn't directly come from university, they hired a lot of university graduates. A lot of the technologies that underlie the internet, speech recognition, et cetera, were developed at universities. And when you talk about industrial research, it's a very tricky thing. My quick characterization of industrial research is an iceberg. the reason I say that is because people say, well, what's the matter? They'll go there, they'll do their research at Google or Microsoft, they'll publish, and everything's great. Look how much they publish. Well, for every paper you see out of these corporations, there's 100 people working on stuff that you'll never see. And which for every framework that's open source like TensorFlow, there's things like TPU, right, the crown jewels that are kept in-house. So it's a complicated dynamic. On the one hand, great companies doing great things. On the other hand, when you think about the ecosystem and you think about the long term, it's not an ideal situation. So Houston, we have a problem.
Is this something that that AI too can potentially help out with? Do you feel like you're able to change this conversation, or do you feel like you're just competing for resources even more in a very small and shrinking supply of talent?
Right. So clearly, the word supply there is key. Because so what's underlying all this? Why are the salaries so high? And some people would say, too high. It's because there's a mismatch of supply and demand. The obvious long-term solution is to increase supply. Now, how do you increase supply? First of all, you don't hire away all the professors, right, so that there are people teaching. Secondly, you don't, increase the requirements and the obstacles for people to come to study in this country and for people to stay in this country, which, of course, the Trump administration is doing, a tremendous peril to our system, right? Sometimes people talk about shooting ourselves in the foot. Well, the Trump administration is not shooting America in the foot, it's shooting us in the head, right? Because the brain drain and so on. So I would say that those are two elements of the supply. And then the third one is women and underrepresented minorities, right? It's crazy if we don't do everything that we can to make computer science in general, but computer science in particular, and AI inside of that, be as inclusive as possible, right? Then we're not dealing with this supply issue. Now, as far as AI2 in particular, we aren't out there educating people. What we've tried to do is create a balance where our research is publicly available on our website through the demos and published papers, where we work with a bunch of professors at the University of Washington, and we try to allow them to share their time between University of Washington and AI2 to make sure they continue to teach and mentor students. But it's very challenging because we're a nonprofit, we can't as a nonprofit offer the kind of financial.
So a lot of folks, there's a small but very vocal contingent of folks out on the world, what won't name, who are essentially see AI as an existential threat to humanity. One, do you what are your thoughts on that view? And then two, if not an existential threat, then what do you see as the potential risks, or is this the new atom bomb, or is this something more benign than that?
I'm really glad you asked that question because it gives me a chance to ask you guys before I say what I say, which probably won't, persuade or dissuade anybody. How many people see AI as potentially an existential threat to humanity? You won't hurt my feelings. Please, raise your hands high. Maybe a few yeses. And how many people are, very comfortable that no problem?
In how many years? What's the time?
What do you mean by no problem?
Like ever?
Right. No, so there are many issues, around. I mean, specifically with the notion that existential threat means that AI is, let's say, in the next 25 years, because I don't really believe that we can foresee technologies beyond that. So how many people think that there's a very real chance, or how many people are comfortable that in the next 25 years, AI will not take over, AI will not achieve what's called super intelligence or even human level intelligence? So this is not a democracy. It's good, it's good to have a set of opinions. Aviv, did you want to?
Oh no, that's like the threats I'm worried about are much shorter term. So,
Yes.
So that's that, and then they're still catastrophic, not existential.
Catastrophic, like the impact on jobs, on privacy.
Yeah, or we not already. Yeah.
Elections.
Elections,
By
diplomacy,
elections.
like ethnic strife, war, basically like massive warfare as a result of manipulation of public opinion.
Right.
I think
So,
also most people that worry about AI as an existential threat worry about beyond 25 years. With the most probably as beyond that.
right. So let me get to that point in a second. Let me first start with one of the reasons that I try to talk a lot about how I don't believe AI is an existential threat in the foreseeable future is because I think we should worry about more real problems and less about imaginary ones. I think that the discussion of existential threat is a distraction from some very real issues: jobs, privacy, bias. Right, there's many issues, and potentially, right, and definitely misinformation is an important one as well. Now, let me talk about the timing issue. One of the big debates. I was literally at a debate between Sam Harris, who's kind of a philosophical neuroscientist, and Rod Brooks, famous roboticist, on exactly this question. And they very quickly got into the timing issue. And what Sam Harris said, which I think echoes what you're saying, is, look, I don't know that it's 25 years, maybe it's 50 years, maybe it's 75 years, but it's so important, it's so catastrophic, it's worse than war and strikes. They believe that superintelligence has the potential to completely wipe out the entire human race, right? That machines will just take over and may choose to keep us as pets, or may choose to not keep us as pets. It's a very, very scary thing, and just annihilate the human race completely. End of story. And so it says whether it's 25, 50, or 75 years, it's so catastrophic, we've got to start getting ready now. Right? So that's one side of it. The other side of the argument is I tried to say, look, when fire was just invented, right? Prehistoric men and women invented or discovered fire. That was probably too early to worry about the effect of AI as an existential threat. So we can agree that there's some time boundary where it's too early, and there's some time where it's too late, right? Probably if it's around the corner. And whether it's too early or too late is a function of, A, when do you think it might happen reasonably, but also a function of what you can do about it, right? So one of the reasons not to worry about even this tremendous thing back when we invented fires, we didn't have the vocabulary, we didn't have the technology. There's just nothing we could do about it. We were still, sketching on the cave walls. So now fast forward to 2018, we have a set of people who are really kind of philosophers and mathematicians thinking about aspects of AI, and that's really valuable, right? It's good to have thinkers. But if you think about a bigger scale engagement in this problem, what exactly can we do about it? Again, not misinformation that Aviv is working on, but what are you going to do as South Park Commons, right, as a project, or what's Google going to do with their resources to fight the annihilation of humanity by superintelligence? It's not a simple, here's 10 things we should do. Let's start a Manhattan Project to fight superintelligence. Let's get $10 billion, 2,000 of the smartest people, get them in a big room. What are they going to do?
Invent it.
In order to study it and
100%. I'm not worried.
Say that again?
Invent it. Do a Manhattan Project to actually invent it.
right. Well, perhaps that's how Elon Musk, not to mention any names, reconciles his comments with his significant investments in AI
I'm pretty
companies
sure
and
that's
technologies.
DeepMind's plan.
I'm sorry?
I'm pretty sure that's DeepMind's plan.
That is their plan.
Yeah.
Yes.
Yeah.
Yeah.
The only thing the only counter to it's going to be so long away we don't actually know why we shouldn't worry even if it's 7,500 years away. I would say that the reason why people think it's so long away is because we don't yet know what it looks like. And I would say that the thing that's sort of between that is how does the human brain actually work? And I think that once we figure that out, it's going to be very quick to converting that into a sort of computer system.
Right. So, but there's at least one other reason conceptually and practically why it may be a long way away, which is those of us who work with computers, which is all of us, know how rigid, literal-minded, and painful they are to work with, right? Even if you don't write AI code, debugging is, excruciatingly painful. Debugging doesn't get easier if you're using machine learning. It gets harder, right? Talk to anybody who's working on machine learning. What's easier to debug, a program or a stochastic program? A program or a program that uses machine learning and deep learning, right? So I think that the other reason is that it's extremely hard to get the programs not just to do what you want, but to go beyond the level of very near what I like to call AI savants. And I'm not saying that you disagree with me. I'm just, people argue about this, right? Very narrow systems that do speech recognition or that play Go. And the other big question that people raise is say, okay, that's true, but it's moving so fast, right? We hear about all these cool AI systems. Surely that's rapidly changing. And the question of whether it's moving so fast is at least one that we can debate on. So there was a line that they used to use in the 70s and later said, what's an AI program? An AI program is a program that makes a phenomenal chess move while the room is on fire. Right? That's an AI program. And now fast forward, 30 years, now we've got a program that makes a phenomenal, right, best in the world Go move while the room is on fire, right? So in other words, right, these programs don't have context, don't have common sense, don't have the ability to do anything more than the computations that they were pointed at by their human creators.
Didn't you just get a big pile of money to invent the very common sense you say to that?
Yes. John, the use of information. John actually, he doesn't just write the newspapers, he reads it. So this year, Paul Allen announced that he's investing $125 million in the Allen Institute, so we're growing. And a big project is to try and work on endowing AI systems with common sense. That's very much of a basic research problem. So we're starting by even understanding what common sense means and trying to define a benchmark where we can measure how much common sense AI systems have. That's how early this is. So I'm an AI optimist. I believe that AI can have potentially beneficial consequences for humankind, and I can back that up if you have questions. And so I'm interested in making that kind of progress, but we're not there yet at all.
I had a question actually. So I read an article recently about open worm, but I don't know if you've heard of this, but it was the idea that they managed to simulate a C. elegans by completing mapping out all 302 neurons in its brain, and sort of putting that network into a robot, and it's sort of simulating the kind of sensors and stimuli that it would receive in the wild. And then it turned out to behave completely autonomously in exactly the way you would expect a C. elegans worm to behave. And that sounds like a really promising proof of concept, but would you think that that could possibly be scaled up to larger and larger animals, maybe even consciousness? What? Yeah.
No, right? I mean, I think you outlined it. If you just look at the numbers of neurons, I'm actually impressed because C. elegans is something that neuroscientists have been studying for a long time. And I've not heard of open worm. I'll look it up. I think, again, these things like AlphaGo or the simulation of C. elegans, there's some real achievements, but that's not going to scale.
You don't think so?
Well, let's not do an argument by tone. That's not going to scale. No, you don't think so? Let's talk about the numbers of neurons in the C. elegans system. Do you know the number? It's
302.
Yeah, and the number of neurons in your mind.
Billions upon untold billions.
Yeah, and even trillions of interconnections. So that's why.
Yeah.
Do you think that we're hardware bound right now?
So let me make sure I know what you mean by that.
For an AGS system.
That's such a great question, actually, because I believe that once we define something as an optimization problem, right, and Go is a great example of this, right? combinatorial space, right? The space of all possible Go games is immense. They always love to say it's more than the number of atoms in the universe, although I never know how they counted or even estimated the number of atoms in the universe. But it's a very large number of possibilities, but we have a very clear objective function, what it means to win, and based on that, and on a huge amount of labeled data, we can build programs that do that. So I think once you've defined what you need to optimize, computer scientists like yourselves are fantastic at, working on the distributed systems challenges, working on the algorithmic challenges, and figuring out how to solve the optimization problem. But if we look at something like natural language processing, let alone even more complex challenges, what exactly should we optimize? Deciding what to optimize, defining that, is actually a very, very hard problem, and it's not even a technical problem, certainly not a technical problem in the same way as, hey, I have to optimize this function. And so progress on that would tend to be a lot slower. So we're hardware bound on some optimization problems. We are lacking insights on how do we structure optimization problems other than give it to 100, 200 extremely talented people in DeepMind and say, figure it out. And then they take some number of years and some number of millions of dollars, and they do.
How closely do you guys work with the Allen Brain Institute?
We're in constant contact with them. Christoph Koch, their head, is a colleague, and he comes by, and their CEO is on our board. But they look at the brain at a very cellular level, very much at the hardware level, and we're looking at mixing deep learning neural systems with symbolic. So there's a wide gap.
Do you ever sort of worry that some problems are just going to be sort of too hard? Like, there's basic problems where, like, say if you flip a coin or roll a dice, and then each time you roll it, you add it to the sum you've got going so far. As you roll the dice, after more and more rolls, the actual space of possible sums is larger and larger. There's just a certain amount of uncertainty in the system. Do you ever sort of get to the point where you say, maybe statistically we don't get past some of these impasses? People keep thinking more data is going to just get you there, but I don't think it's always the case.
Right, so 3 points. First of all, it's definitely the case. Some people say, oh, superintelligence is a foregone conclusion. But in fact, we may well live in a universe where our brains, even augmented with the best technology that our brains can build, are not sufficiently sophisticated to solve the problem of intelligence, to understand themselves. That's even if you're a materialist, in other words, you don't believe in souls, you believe that everything is built of atoms, that's completely possible, right? And so that's a possibility. I don't worry about that because as a practical AI person, I often think of what I'm doing as combating artificial stupidity, not really trying to achieve human level intelligence. In combating artificial stupidity, there's so much stupidity around of all kinds, artificial and natural, that surely we can help. And I'm not joking about the natural stupidity. You hear, so for example, self-driving cars, right? 35,000 highway deaths each year in this country, 1 million people injured. Estimates that about 80% or more of that could be prevented using technology, right? That's combating artificial stupidity. That's combating my teenager who texts and drives and his friends who drink and drive, right? I don't want to be killed by those folks. I want the technology to help me the same way that anti-lock brakes and airbags, cut deaths. So I think there's a lot to be said there.
Progress to be made even.
Yeah, even without that.
Well, John asked you about common sense, and I started thinking about Carmen Tversky's work in behavioral science, and specifically the book Thinking Fast and Slow and System 1, System 2. It sort of feels like we've built the more sort of plodding, methodical system and not the quick, intuitive system. Do you guys, I don't know, does that resonate?
Yeah, well, again, several things to say about that. One is that I don't think that System 1 and System 2 map very well to the computer for the following reason. Andrew Ng recently said, anything that you can do in under a second, the computer can do today or will be able to do soon. So that sounds a lot like like system. And what he's referring to is, for example, visual processing and auditory processing. It's a quick statement and it's a caricature. I don't agree with it fully, but it's not a bad caricature of what some of our systems could do. And then at the other extreme, you're right that when something is very rule-based and very structured, and there isn't room for nuance and so on, then again, machines shine at that, right? That's something like Go or, mathematical theorem proving of certain sorts. So what people can do, we're actually learning more and more about what's uniquely human, because there is this moving goalpost things. Many things that we thought were uniquely in the province of humans, we've now recognized are doable by machines. So what is it that humans are uniquely capable of, and what is it that the machines can do? That boundary keeps shifting. But the one other point I want to mention about Kahneman and Tversky and Kahneman, they went to great length to document cognitive biases, right? The kind of mistakes that we make in our thinking very reliably across the board. And not only we make them, doctors make them, right? And so, for example, thinking about probabilities, base rate neglect and things like that. Well, they make these mistakes to our peril, right? We walk into a surgery decision, a critical hospital decision, and the doctor, left to his or her own devices, will make a rookie mistake in probability calculation. Whereas if that person was augmented by a machine that does these calculations correctly every time, doesn't get tired, doesn't get distracted, and catches those doctor errors, we'd all be a lot better off. Third leading cause of death in American hospitals, physician error. So Tversky and Kahneman remind me of this point that we really want to build, that I think AI should stand for augmented intelligence.
Thanks.
Yeah, the pessimist.
So this is kind of related. On the heels of the Facebook news, it seems to be troubling for a lot of consumers at this moment that so much AI seems to be developed and definitely wielded by ad-supported platforms, using opaque algorithms to optimize for paid political gain or to maximize the time you waste. But on the other hand, if consumers wanted more control, it feels like they need an advanced degree to really be able to press the buttons and understand how to protect themselves. So I noticed that you are a writer of AI regulation op-eds, and I was wondering if you could talk a little bit about the near-term AI regulations that could maybe strive to return the power to consumers.
Sure. Well, there's so much in what you talked about that I'll just touch on a couple of threads and we can continue. First of all, right, we do have some power as individuals, and so I deleted my Facebook app from my phone just recently, and I don't delude myself that it'll change the world, but I felt good about it, and you know what, and I was wasting less time. So that's point one. On the topic of regulation, it's a very tricky topic. So I'm actually not a huge fan of regulation and regulating the AI field in particular. We're in a globally competitive world. Regulation is such a blunt instrument. It's so easy to have the wrong regulations, and then we suffer from that. What I wrote about and what I do believe in is regulating AI applications, right? So whether it's cars, where we had an unfortunate tragedy of somebody being killed by an AI car, or whether it's toys, right? We have AI Barbie that's eliciting information from our kids, and has the ability to upload it to God, God knows where. So I think that we should think about those applications very, very carefully, and they may make sense in terms of these social apps or apps that are designed, to be addictive to us. That we should regulate those. So again, just touching on a couple of things. I don't know if that was satisfying, or you want to continue.
Do you have any thoughts on not just Facebook, but the entire ad-supported model and how that maybe is at a baseline by default meant to be exploitative of big data sets and
So I guess I'm not an expert on this issue, but just personally, I have mixed feelings about the ad-supported model. So one is, and there was a beautiful article in the New York Times a while ago where the title sums up the entire article, the tyranny of convenience, right? We have these systems, they're incredibly convenient, and in exchange we sell our soul and our privacy to them, and people are shocked when they find out, right, how much Google and Facebook and others know about them. So on the one hand, it sure seems like a negative thing. On the other hand, all these things are free, right? And there's so many places in the third world, or people who don't have the resources, say, for a paid service, where the fact that they can have access to these free services is a huge equalizer. Right? It means that, right? I mean, there's people who don't have access to the internet, but if you have access to the internet, you get to use Google. And that puts you in a much better position than if you had to pay for Google. So, yin and yang. Yeah.
So there's obviously impacts that AI is going to have on the world, and some of them are going to be negative, and some of them are going to be positive. You're trying to sort of advance AI as part of the mission of your institute, right? Is that an accurate assessment?
Well, our mission is AI for the common good. So we're trying to advance AI for good purposes, but it boils down to we're trying to advance AI, yes.
Well, no, that's what I meant. Advance AI for the common good. So I'm wondering, I look at sort of the job postings and a lot of these places that are trying to advance AI, and I don't see there often being positions for people who are trying to understand AI, understand the impacts of the things that are being developed either in that lab or in other labs. And then sometimes you can ensure that it's for the common good by creating more AI. Sometimes you need to do other things. But you need to have a deep knowledge of the trajectory, which you're only really going to get if you're actually in one of these organizations. And so I've been curious to see why there aren't very many people. There's a few like Jack at OpenAI who are where there is some investment toward mitigating these unintended negative consequences. And I'm wondering if that's something that you guys do explicitly beyond, let's say you're writing op-ed, which is not your full-time job.
Yeah.
People who are where is the team of people whose full-time job is to do that? Maybe it's a way to think about it.
Yeah. So I guess what I would say is that when we identify, and maybe we should be studying it more, but I mean as a society writ large, potential negative consequences, we should and do to various extents get engaged in that enterprise. Right now, I'm not aware of very many teams to working on mitigating the negative effects of AI in general, because it's not clear what they are. But there's certainly a lot of people working on fake news and misinformation. Maybe not as long as you have, but no, there are startups, there are teams. There's more and more work on this in various contexts because we've seen that it's a problem, and now we're trying to deal with it in various ways.
Right. So after there's a sort of catastrophic set of problems, so a number of countries had very, very major impacts, then in a way that may actually be irreversible, that's when we should start doing the problem, as opposed to, let's say there's a new threat on the horizon, let's say manipulated video audio. Is it the point where it's after that's being used to start several civil wars, then we should, or should we be doing it before, is maybe my question. And how should that happen? What should create that incentive, or who should be doing it? Maybe nonprofits. I don't know.
Yeah.
So trying to advance the
but tell us how you really feel, Aviv. I completely and utterly respect what you're saying, and I would say that probably we can be more proactive. Again, as a society, very rapidly we get into the question of how. And that's a very difficult question. But
I found it to be super difficult to answer if you don't have people who are spending a lot of time thinking about it.
But we do have some people who are spending a lot of time thinking about it, and they kindly share the output of their thinking. And a lot of those outputs haven't been very satisfactory either. They look very mathematical, very philosophical, not very practical. I don't think that what I've seen out of, say, OpenAI, where there's a ton of really smart people, is going to stop any civil wars.
Oh yeah.
Yeah.
So I live in New York now. I go to Montreal every once in a while. The communities there for machine learning and whatnot are very different than they are here. And in particular, this conversation almost never comes out. So I'm curious what they talk about in Seattle.
I would say that everything that we've talked about, and yeah, please feel free to, people have lives and, things to do. I don't. I do, but it's in Seattle. I'm not going to put my 7-year-old to bed tonight, so I can hang out with you guys. I think a lot of these conversations are very much being had in Seattle. I would say that there's an enormous number of people, right? A lot of the folks here have chosen to do their own projects or spend time in big companies and seen, both the pluses and minuses of that. A lot of the folks in Seattle are working for, Google, Facebook, Amazon, Microsoft, and that does change the nature of the conversation. I think a lot of people are very concerned. I'm sure here too. We just haven't gotten to it about jobs. Right? I mean, what is the impact going to be on the labor force, and particularly the weakest members of the labor force, right? I'm really worried about the people who didn't finish high school, who didn't finish college, working in transportation, working in retail. They're not going to become data miners, right? Some people say coal miners to data miners. That's not a reality. How are we going to help? How are we going to help those people? So, but I'm actually very interested in what you said. So, can you say a little bit more about? So, what do they talk about in Montreal?
Machine learning in particular?
Well, just different from here.
Referencing, yeah. I mean, we talk about research. We talk about where things are going. We talk about what's actually realistic about this. We talk about things like fairness, sure, but in the context of what we can do today. A lot of the discussion about whether something is, I'll pass over that part, but it's not a fatalistic question.
Yeah, and again, this is.
It's also, we talk about applications. We talk about what are the things that people are doing today that are good. And I know a lot of that, I'm sure, is happening in Seattle as well, and you're at the forefront of most of it. So the question was guided towards what can you tell us about things that maybe are happening in your incubator, or even the things you see around UW?
Sure. So let me. I do agree with you that the conversations had kind of a negative tinge to it. So to balance that a little bit, let me just mention a few of my favorite positive things. We talked about cars and that potential. We talked about healthcare and enormous potential there, both to drive down costs and to improve outcomes. I mentioned Semantic Scholar, where I think we're working on making it a tool that is going to empower scientists, right, to be better at their jobs, not just in terms of search, in terms of down the road generating hypotheses and things like that. So I think there's enormous potential for the positive there. Let me just mention a quick example, since you mentioned our incubator. We have a company called Blue Canoe that works on helping people pronounce English better. And it turns out that there are a lot of people in the third world, but also in this country, very smart engineers, but they struggle, with communication because it's hard to understand them. So they figured out how to gamify pronunciation, lessons, and early stage app that's using AI to hear your pronunciation, analyze it, and teach you how to, pronounce English more clearly, which, generally is a good thing. So I think there is a lot of that. And the one last thing I again want to reiterate is when we look at the criminal justice system, when we really look at any system in this country, there's a lot of concerns that people raise. Oh gosh, if AI gets involved, it's going to be a disaster. So there was this recent study, about parole decisions that showed that, an opaque AI system built by a contractor was, making decisions and quite possibly the wrong decisions. And that study was appropriate and helpful. What it neglected to note is how humans who are racist, who are sexist, who are hungry, right? There's a study that showed that, when judges are hungry, they make different kinds of rulings than when they're not hungry. And, it's crazy, but you really don't want the judge to issue his or her sentencing, right before lunch, right? So humans have been doing a terrible job at these things for a very long time, and AI has the potential to help them. So hopefully I help to redress that balance a little bit.
I got one.
Like one or two more questions?
Yeah, I got one boring question. So I think you guys did an interesting job of looking at things beyond just machine learning and full hands-on research. So what else are you seeing in terms of advances in other AI-based subfields that you're excited about?
Yeah, so the pendulum is very much swung in the machine learning direction, and that's been over a number of years, but accelerated with the success of deep learning. At the same time, I do believe that it's going to swing back to some extent, not that people say, machine learning, it was just a fad, but there's also the recognition of limitations specifically around the data efficiency, right? So we're able to learn from one examples. These systems typically take thousands, if not millions of examples to learn their models. That's very problematic. So people are starting to talk about zero-shot learning and transfer learning. Semi-supervised learning has been an issue for a long time, right? How do we build systems that require less data? So that's one whole strand. And the use of knowledge and reasoning and so on is an attempt also to do that. If you start with more knowledge, hopefully you need fewer training examples. So we look at that. A second dimension is brittleness, right? There's a lot of papers that have come out that show these wonderful systems. They do really well on the training set, they do well on the test set, but then if you introduce an adversarial example, if you let people play with the data distribution, they fail. Recently I saw a paper on 1 pixel attacks against vision algorithms, right? Since like a lot of you have seen it. You change 1 pixel in the image and now it makes a mistake, whereas it used to get it right. So these systems are very brittle because of their slavish adherence to the data. They have no common sense. They have no notion of, wait a minute, this doesn't make sense. And so we're looking at how do you have more of a balance between the great things in machine learning and symbolic and knowledge representation on top of that. But it's very challenging because marrying these formalisms is very much an open problem.
I'll ask the last question. So you described yourself as an AI optimist. What is something kind of specifically that in AI that you're optimistic about, that you feel like you're kind of uniquely optimistic about, but maybe other folks out in the field are less optimistic or feel less strongly?
Great question. Let me start by first of all saying I'm an optimist in general. I think the 2020 election is going to be very, very different. But I digress. I actually rushed from my flight yesterday. I rushed to my hotel room to see Stormy Daniels on 60 Minutes. How many of you saw that or online or otherwise? Okay, well, let me just tell you, she was very dignified and very credible, and we just leave it at that. But back to AI, I think that I'm really optimistic about AI saving human lives in a very crisp way. And I think the conversation that we're having, which is quite negative in many circles and quite informed either by Elon Musk or by what's happened with Facebook, the conversation responds to things that happen. So right now there's a lot of fear about self-driving cars. When fewer people die each year on the highways, that conversation will change. So I'm very optimistic about AI being used to save lives. And the things, and I'm terrified about the jobs thing, but also about cybersecurity, right? So cybersecurity is already a nightmare. And we just recently learned, right, that the Russians, got access to our, power grid and nuclear power plants. Well, you ain't seen nothing yet, right? What if you turbocharge your viruses with AI, right? So, I'm sorry?
Or your social engineering.
Or with social engineering. I mean,
that's Facebook. The NSA are good enough. Destroy them back.
Yeah, but so what am I optimistic about that other people aren't necessarily optimistic about. I'm very optimistic about this country and our ability to innovate and to continue to be leaders in this space, so long as we don't screw up the immigration thing. So I guess I'm an optimist, but you can see, like, I'm not 100%. I don't view the world through rose-colored glasses.
Is Mr. Allen doing any work to help with the immigration stuff?
I really can't speak for him, but generally he's been very active in scientific philanthropy and in Seattle-based causes like helping the homeless or with things like Ebola. He's not focused on political issues on either side of the aisle, as far as I know. I work for him, not him for me. So he, but as far as I know, he's not working on that right now. Thank you so much.
Thank you.